So now we are moving to the second roundtable for the defense session, preparing and developing artificial intelligence to meet these needs. So let's welcome a second moderator, Morgan Ossola. So he worked for 15 years at MBDA, where he held several positions in the engineering and strategy directorates on some of the key Air Force programs like medium range ground-to-air systems, SAMT, and the Future Combat Air System, FCAS, as well. So he supervised the remote carrier concept study for the Franco-German FCAS cooperation until 2022. So he's currently Associate Director for Program and Partnership at Helsing, France, in charge of the air domain. Morgan, floor is yours.
Thank you very much, Jérôme, and thank you to my panelists to bear with me for the second leg of your morning marathon. I don't have the excuse of coffee anymore, so I guess I'm going to have to be dynamic on this roundtable. So quick introduction before giving the floor to my panelists. I think we've just heard between yesterday's introduction and the first roundtable this morning that the range of applications for AI in air power is very, very broad, and the transformation potential is unanimous as well. But we've also heard from yesterday's introduction that the industrialization wall is still very present. So it means that there's a number of challenges that we need to tackle if we want to achieve the vision that has been delivered this morning, and especially the framing that I like, which is multi-level AI integration. The reasons why the industrialization wall is still fairly present in aerospace and defense, I would argue, is because AI is quite a singular technology in many ways. Couple of examples. Yesterday, we've heard that defense was a data-rich environment. Yes, it is a data-rich environment, but data in defense is usually siloed, classified, proprietary, and very much lost. It means not recorded, and not exploited in the majority of the time. AI is also stochastic, and machine learning precisely is fairly stochastic. And this is in fairly direct contradiction to the existing software assurance standards that we are typically using in the domain. So this is another challenge. AI is also civilian driven in terms of investment, in terms of talent pool. And we know this is a challenge as well in both sides. This is a challenge because the requirements of perennity and sovereignty that are requested by procurement agencies are very difficult to fulfill for civilian companies. And it's also a challenge for defense companies to attract and to retain these talents. And finally, and maybe most importantly, AI is fast-paced, extremely fast-paced at the moment, and which is in a fairly strong contradiction with the duration of the development cycles of the military platforms, which is longer and longer. So all these singularities taken in isolation are not insurmountable. And I would quote the example of electronic warfare. Electronic warfare is not only signal processing technology. It's a complete off-board infrastructure. It's a complete organization that has been put in place for the purpose of updating the electronic warfare libraries in the tempo of operations. So we know how to tackle data-driven capabilities, but this is a fairly holistic transformation that it requires to make it happen. The problem of scaling AI, I would say, is that these four singularities of AI cause compounding challenges. So we have all these challenges to address at the same time in order to scale. And some of these challenges are present in a quantitative manner that is fairly unprecedented. And this is the example of pace that I would like to illustrate with this slide. We've all been involved in what we called Moore's law, which is the evolution of compute in CPU, and that has always been a challenge for the weapon system development. The Moore's law of AI doesn't really exist, but I want to share this data set that is here. If you look at since the inception, especially since the inception of transformers, the quantity of compute that is used to train large AI models have been multiplied between a factor 4 and a factor 7 per year during the last couple of years. So this factor 4, factor 7 is not that impressive, but if you compound it on the duration of one programming law, for example, 2024, 2030, which is the current programming law in France, that is a factor 10,000 to 100,000. And that is a key challenge that we started discussing this morning in terms of how it impacts systems engineering. So if we want to harness the pace of development of AI for military capability, that's actually a fairly holistic transformation that we need to put in place that is well beyond technology. And the framework that I want to share with you and that has driven our discussions in the panel is the framework of the US Air Force's next generation acquisition model. This comes from slides that are only a couple of months old. And I would argue that the NGAD program is not stopped, it's paused. And the reason why it's paused is because they've understood that they need to get this right in order to get NGAD going and to get this multi-level AI integration into the program. And as you can see on the slide, getting AI multi-level at scale in an operational capability that provides enduring tactical advantage is actually about many things that are well beyond technology. It's about the digital infrastructure that you need to put in place. It's about data governance. It's about the relationships between the industry, the civilian industry, the military industry, the end users. It's about digital engineering processes. We've talked about system engineering this morning. And it's about also contractual mechanisms and business practice. And this is this holistic transformation that we have to put in place to scale AI, which is why I'm very happy to have a great panel to discuss these topics this morning. Philippe, you are a prominent leader of the future air power in France, and you've acted as such for decades now, but you're also a tireless craftsman of the defense AI industry for more than 1 decade. Pooja, you're now in a strategy position in Airbus, but you've also been a lead data scientist for most part of your career, and you've experienced these ML development and deployment methodologies for yourself. And Yonatan, you've been presented this morning as head of digital projects for MBDA, but you're now also CTO of NEOD Systems, which is precisely MBDA's answer to tackle these challenges. So this is in this capacity that we will hear you this morning. So all these topics that we need to tackle to scale AI are very diverse, and maybe let's not start with the most hardcore engineering discussions. And interestingly, the first topic that came out in the preparation of this roundtable was the topic of the relationships between the civilian and the defense industry, and relationships between the primes and the end users. Philippe, the role of DGA in shaping the defense industry and knowing your personal success in the field, would you care to share your views on this aspect?
Oh, thank you, Morgan. So first, it's important to recognize that for the past 10 or 15 years, there has been a shift where the most disruptive technologies, including AI, are now essentially driven by the civilian sector, and we can't match their massive investment. And so given this reality, we need to find a way to capture this vast amount of innovation sitting in the civilian sector and to harness its creativity and inventiveness. And so we need to federate an innovative ecosystem made of startups, labs, and SMEs, and a dynamic one where new entrants are encouraged and where there are also exit pathways. Now, what we want to do is not simply to develop out-of-context technologies, which look impressive, but which lack true application for the defense sector. We need to focus on technologies with true added value for our defense systems. And therefore, we need to co-run, to run in parallel exploration of future concepts and development of emerging technologies. And therefore, we need to build bridges between the prime companies, prime industries, and these non-traditional players. And a prime example of this is the partnership in the US between Boeing and Shield AI, which has demonstrated the power of this kind of cooperation between both sides. On French side, we have initiated this kind of approach in 2018 with the launch of the man-machine teaming project. And again, we have taken this path within the NGWS program, where we have allocated what we call tokens or flex tokens to prime companies like Dassault, Thales, to launch proof of concept projects with new players to develop AI or man-machine interface technologies. And this project have proven to be quite successful, but have also highlighted some significant challenges. And there are different timeframes, different structures, and also legal and security considerations. However, this proof of concept project have helped us to test AI in real-world defense applications, and they have provided learning experience for DGA and armed forces. And they enable us to feel the real value of AI and to refine our approach to specify it. And that's an essential point because the very first step to implement AI in our defense systems is for the end users to be able to express their needs clearly. And it reminds me a discussion I had with the French Air Force a few years ago within the scope of FCAS, and I was pushing hard for AI, for autonomous systems. And I was responded that they were struggling to integrate such requirements in the common operational requirement document. And therefore, it means that we need that beyond MMT or beyond NGWS, we need to increase operational experimentations in order for the end user to get used, to get familiarized with AI, and to get comfortable to specify it. And that's an ongoing process within DGA. We have some talks with different companies, including Helsing, for instance, to test AI within the Tiger helicopters, drones, electronic warfare.
Thank you, Philippe. I think this importance of early experimentation, early testing, iterative development, and ultimately user-centric design is something that is key to AI, and that is a prerequisite for specification, as you said, which is a real game changer. Pooja, you've been involved in this kind of experimentations, both in the civilian and the defense world. Can you share your views on this and more specifically on the specificities of defense with regards to this approach?
Yes, definitely. Thanks a lot for the question, Margaret. So user-centric design, like you already mentioned, is quite an important concept, and it's quite a simple concept. The concept is all about putting user who will be using this software at the end of the day at the heart of the development process. And how do you ensure that this happens is basically to involve them in each step of the engineering design process. And this is said very simply, but it's practiced very difficult. And when we need a feedback that is needed from the user on everything, even on the description of the specification, on understanding how the algorithm development is ongoing, and if this is going on in the right fashion, if there needs to be some feedback that needs to be integrated, this is going to be a more time consuming process. But if this philosophy is followed, which is very much about the systems engineers participating with the customer and developing or co-designing and co-developing the solution together, then the success rate of the the end implementation or the end deployment is going to be the highest. So I think we all very well understand this, and following user-centric design in regular domains where you are just developing for internal usage, or let's say internal and service deployment, is already difficult. But then we are talking about the military domain on top of it. And we are not talking about the development and design of traditional software here. We are talking about AI module development, which brings an additional layer of complexity because usually at the beginning of the process, the data is not fully available. It's only in iterations that the data becomes available, and you need to sort of take that whole unstable or uneven ground coming from the AI world into account when you are doing this user-centric design. And that's extremely important. And in Airbus, we have been in the research and development pipeline, we have several topics where we try to see that an end user, for instance, if you're developing something for the crew, we try to engage with them and to see if we have any feedback coming from there, right from the early design phases. For instance, in the research, we had a project around NOTAM parsing, which is the notice to the airmen, where we were, this is a very simple AI topic. You just do the name entity recognition and you have the response coming out of there. Of course, it has the complexities because the corpus is not the general English corpus that you, natural language corpus that you have on the internet. So you need to do modifications, but it's also a lot in how you are presenting this information to the end user. If they are perceiving it the right way, is this what they encourage? It's about understanding the goal of the user, what they need to perform, what's their intent, are they enjoying interacting with the system, and if their intent is fulfilled. So this is the part about user-centric design that becomes extremely important to think of it. So one example that I gave you was from the civil domain. And we also have, I think yesterday it was spoken about Airbus Up Next, which is an entity where we develop demonstrators basically. So we don't really think about what goes into the product or what becomes reality in the product, but we just want to prove a concept. It could be a tangible concept that we want to prove, and we bring on board the components which are available mainly from the carts, and then we see if the concept can be proven. In this stage also, in order to say whether the demonstrator succeeded or not, we conduct lots of flight tests. And this is where we engage with the end user again to see if the user-centric design principles can be taken into account during the development. So as you mentioned, and as Philippe mentioned before, it's extremely important that we do early testing. We engage the user, end user, right from the beginning into our development process in order for the deployment to be as seamless as possible. That's my view on that.
Thank you, Pooja. We are then in a bit of dilemma, because in order to specify, we need to experiment. In order to experiment, we need data. And usually in defense, data is not easily accessible or not accessible outside any framework contracts or whatever. So there is a data challenge and a data liberalization challenge, which needs to be opened up, but still in a manner that is secure. So Philippe, how do you go about this data liberalization challenge in the MOD?
Yes, so before talking about the data liberalization or decloisonning, we must come back to the foundation, which is data collection. And here we can make the statement that the defense sector generate vast amount of data, especially through the advanced simulators. These simulators are critical for training, but they can also generate data which, if properly stored and utilized, can have a lasting value to train our AI algorithm. And that's exactly what we are doing, for instance, within the scope of the Rafale simulation program, where we actively explore the way to retain data to ensure future utility and accessibility. So once we have collected valuable data, then we need to break down silo in order to enable more streamlined data flow across various stakeholders. And to achieve this, we need to tailor the data access to each actor's need without compromising security. And that's where what we call DevSecOps approach is crucial, blending development, security, operations to safeguard sensitive information while maximizing usability, data usability. So an example of this is the DHE, the Data Hub embarqué or embarked Data Hub, which is a Navy's, French Navy's initiative. And this is a flagship project for data collection and sharing. And with this DHE, it enables to collect data from various systems on board frigate La Provence. And it will store, it will index data, it will create a structured database, and it will prevent from what we call data loss or data evaporation. And beyond this, the DHE enables the development of simple low-code application on board and the development of more complex AI-driven application on ground, on the headquarters. And it opens up a large field of possibilities to enhance tactical decision-making, and the French navies are already identified several use cases related to sonar analysis, electronic warfare, situation awareness. And so some tests have been carried out in late 2023, early 2024, and now the navies is planning to scale up to other frigate. And here the aim is to establish a more data-driven, more interconnected maritime operation. And with this DHE example, I wanted also to highlight the need for AI tooling. We need tools to develop our models, to train our models, and to retrain our models, because in an evolving environment, we need to keep up with our capabilities. And we need to do that on ground, but also on board. And I have in mind some initiatives, European initiatives. So first in France, of course, Artemis, which is more focused on the central or ground operations, but also in Germany, so the KI backbone, which is more focused on onboard operations. And for me, as a conclusion, data liberalization is not only about removing barriers, but also creating framework to ensure that data will actively value to operational advantage.
Super clear. Thank you, Philippe. So I think you've just touched on the point on DHE being a first, I would say, bottom-up initiative to create the whole digital infrastructure that we need to put in place to deploy AI. Yonatan, and you mentioned, Philippe, the simulation environments as one of the key parts of this digital infrastructure. Yonatan, you've touched on the topic of simulation environment in the first roundtable. Would you care to share your views on this?
Yes, of course. Yes, indeed. I think I have two examples of how we can turn legacy systems into AI augmented ones. I think, yes, the flagship, I agree with Philippe's DHE. Back in my MBDA period, when we have been part of the prototyping phase, we have developed a concrete first data visualization app into this DHE environment. And I think it was the first time that all industrial at subsystem level, effectively, because in the frigate, you have a vast number of systems, including MBDA firing post one. And I think it is one of the best example we have so far in the data liberalization challenge. You have to embark a server that collects every piece of data coming from various type of weapon systems, and this system were are now part of an ongoing evolution through data DHE apps. And once you deliver first very very basic capabilities such as data visualization, you can talk with the users to say, okay, let's turn it into a more powerful app, possibly with predictive behavior analysis. And I think for firing sequence, for especially the MBDA use cases, we have demonstrated that once we have an effective data visualization tool, we can engage the discussion with the users, and then talk about I would say the more fancy ones, the AI one. So when it comes to data visualization challenge, you must talk to your customer with very first basic things, and then turn it to a more powerful one afterwards. And second example, it is an ongoing use case that I know developed within Neo Systems, which is a subsidiary of MBDA France. This battlefield use case, we know Acheron MP or MMP system. It is a very powerful system. You have a lot of data coming from Acheron system, because you have a firing post, images at surveillance level because of the firing post, images at the missile level because once you fire, you see a lot of things, and drones connected to the systems. And effectively, once you are able to demonstrate effective use of this data at the simulation level, you can engage as well the discussion with the concrete users of the system, or how to collect it effectively and how to augment step by step the system and gradually. Yeah, I think it's very basic stuff for the first use case at data visualization level for DHE, and then at the simulation level for battlefield use case in NEOT systems.
Pooja, I think Airbus is a big player in the domain of digital infrastructure, both coming from, again, commercial aircraft, but also in defense. What's the approach to the digital infrastructure that supports the MLOps activities in Airbus?
Yeah, you mentioned already as a part of your question, MLOps. So we have several things here. So we have to think of what type of AI we are developing, and internally in Airbus we have sort of rough value streams around AI. One for internal process optimization, the second one for products and services. When it comes for the internal process optimization, it's all about your internal data. You know the data classification of it quite well. And usually there is at least a baseline data management practice that's already in place, which talks about what's your data quality, tools and services to check the quality, quantity of data, and the data lineage, for example. So all of this are the building blocks of this platform or the digital infrastructure goal that we're all talking about here. So with that, it then becomes easy to think of putting in place either a more generic MLOps framework or a model ops framework, where you will think of delivering your developments in the form of models or model as a service, where models can be then accessed or rather democratized throughout the company. They can be called in several different applications, and the end users can see the benefit of them, even if they did not themselves train these algorithms with the data that they collected. That's one way, one way of deploying the AI developments that we have internally. And in our commercial division, this works quite well. We have the COTS solutions in place where data can be stored, it can be pre-processed. We all know data pre-processing or other processing of data, and data engineering is an extremely important step when it comes to the AI methodology. And this can be done on that. So there are several components coming from the parts which are interrelated, letting us perform this operation. But then there is the products and services area where you're actually talking about embedding the AI models that are developed on the product. So there are two phases of it. One is and there are several ways of thinking again. One is you use the data which you have available. In the military domain, data is scarce, so we use if there is a public data available, we use it, or we generate it from simulators if they are available. If the simulators are not available, we try to build the simulators and then try to generate some data. So several granularities there. And then we develop the algorithm for a specific hardware, embedded hardware. So it's not going to be, yes, you can make use of the infrastructure that is present, but the idea here should be to experiment soon and to fail quick. And by this, it will pave the way towards what's the right thing to do at the platform level. And there, what we try to do is, just like I mentioned, we try to bring in COTS, somewhat matching the specification of what we are looking for, and try to experiment and fail. And this is how we are. And we all know the problem of the embedded hardware challenge. Yesterday, several developments were showcased by companies like Thales and others, where they develop solutions for the embedded hardware. So there is this real problem of embedded hardware. So in our commercial division for internal process optimization, we are quite okay. But in the defense domain, we are still looking for solutions and digital infrastructure that will integrate, the AI assurance methods that we were talking about yesterday, the methods and tools that are needed for performing the assurance, verification, validation of the algorithms, and all the research that we are conducting with Aniti, for instance, which has to come back and get integrated into this digital infrastructure. This is still some way to go. And all of these are parallel developments, as in we are thinking about the use cases. We are also thinking about how to get there. So all of this is a parallel development. So there are lots of parallel tracks feeding into one another. And I see more of it as a holistically developing concept now. So this is the Airbus perspective.
Thank you. I'll maybe just chip in to add the additional perspective of Helsing in this, because what you've just described, which is basically being able to retrain and redeploy AI models at the far edge, whilst maintaining safety and security in this process, is actually key, and we believe it's actually key to defense, because being able to update the AI models in the tempo of operations, in the tactical tempo, and that's what we see in Ukraine right now, is a foundational thesis of Helsing. So this is what AI backbone is all about, being able to retrain and redeploy AI models on the battlefield in the tempo of operations. So that's I would say, the final part of this digital infrastructure that needs to go from cloud to edge. Last topic maybe that was very prominent in the US Air Force next generation acquisition model is the notion of open architectures. If you want to be able to deploy AI models across platforms, if you want to be able to update them again in the tempo of operations, there is a question of open architectures in the mission systems of the systems in which you want to deploy. I'll just click on that. So this is the vision that the US Air Force is building right now, and basically considering the software and in particular AI as almost an independent organism from the platform in which it is deployed. And if you look at the timeline at the bottom of the slide, this is a very ambitious objective, which is autonomy architecture enables separated vehicle and autonomy acquisition. So this is a fundamental paradigm shift, but we believe that if you want to exploit the pace of development of AI in order to gain a tactical advantage, an enduring tactical advantage in front of evolving threats, then open architectures are one part of the toolbox that you need to have. Philippe, do you want to share your views on how French MOD approaches open architectures?
Yes, so for French MOD, open architectures, I would say open and modular architectures are strategic necessity. As you mentioned, there is an evolving environment, threat environment. The pace of technology development is accelerating, and so our platforms must keep up. And therefore, we need architectures which are inherently flexible and scalable. Beyond adaptability, this approach will help the French MOD to leverage the best expertise available by inviting contribution from a wider set of players. And this competitive landscape will not only foster innovation, but it will also drive the cost down, and it will also mitigate the risk for the French MOD of dependency to a single source supplier. However, this doesn't come without challenges. First and foremost is the standardization of the interfaces. If we want to achieve this, if we want all components to work seamlessly in a unified system, we need consistent standards across all interfaces. And this is not small feat when we work with multiple industry coming from different nations and all coming with their own practices, own processes, and sometimes proprietary architectures as well. The second challenge is about the way to incentivize the defense industry. Traditionally, because this model, this open architecture model, will disrupt the traditional business model, where traditionally proprietary architectures have offered them a long-term and stable revenue based on through life maintenance and periodic updates. So here we need to propose a new deal based on, for instance, intellectual property, or based on much more frequent updates, which will benefit to agile company, but which will need a change of mindset. We need also to acknowledge, to recognize that open architecture will also require higher initial level of investment, because these kind of architectures are, with a given level of performance, are more expensive than proprietary architectures. And therefore, there is a balance and trade-off to be made between upfront cost and longer-term advantage. And finally, cyber security. Here also, open architectures will be more vulnerable because of this wider access to interfaces, providing more cyber entry points. And therefore, we need robust approach in terms of cyber, and we need also to balance between openness and security.
Thank you. Yonatan, do you want to add something on the view of a weapon systems prime on open architectures?
Yes, I think it's crucial. And this slide really open up, at the autonomy level, the open architecture. So it is an example for autonomy, but basically for any new C square, if we try, any new C square systems that needs to embed an AI system on it, if the prime offer a monolithic approach, it will end up into I think a failure today, because first for the engineering process and for the frequent updates that we need. We've already talked about the fact that we need ever evolving AI systems and the performance come from new data, new type of target you need. So when you add, for example, image recognition tools that need to update, plus AI tools for decision process, and you combine it with more basic features that you need to evolve for HMI, for example, you need to embed, you need to develop a modular, a service-oriented architecture. And then it will lead to a modular approach. And once we've already raised these 2 points, you need to embed the whole AI ecosystem. I don't know if a detection recognition identification tool is already in use in DGA. DGA pay already a license for that. You need to use it in another context. You have to install it, for example, into this C-square example I already mentioned, to infer on this data. And that's the kind of the new deal that we need to organize, that you just discussed, Philippe. And I think it's the way to go.
Thank you, Yonatan. And thank you to the three of you for your contributions. We are about on time, which is, I'm the first to be surprised about that, which is great. So let me spare like a minute for the conclusion, and then we can take questions from the floor and from the remote questions. So Philippe, I like this New Deal idea, which includes, as we said, digital infrastructure that goes from cloud to edge to manage the end-to-end life cycle of the AI models. Building bridges between civilian and industry, between stronger bridges between the industry and the end users, fostering the control and the standardization of the simulation environments that are key to these processes, and open architectures with the challenges and the business practices that you mentioned that are key to go alongside them. Any questions? So there is an interesting question. When do we think it will be possible to fly AI on board for flight critical functions? Who wants to take that question?
Okay, maybe I can take a cut at it. I mean, yeah, the question is quite specific. It says about flight function, flight critical function, flight critical function. There are also mission critical functions, so there are different. And if you're talking about the flight critical functions, we are preparing the ground. We are preparing the ground for it, as in the AI algorithm developments are in the progress. We are exploring here, and they are in research and development, like I mentioned. And we are looking at what are the problems which are emerging as we explore this vast field, coming with its own challenges. There's problems around having sufficient quantities of data. There's challenges around synthetic data generation, and we are trying to augment all of that to generate a performant AI module, which gives us the necessary performance guarantees to be embedded on the aircraft. So we are definitely in the preparation of it, and we are definitely planning for it. But yes, we will see the future as to what it unfolds and how the regulations and the standard space will develop. It will actually depend a lot on this space, and we will see. As I already mentioned, we are doing parallel developments into how this will get integrated finally in the flight. And then the mission critical part. I think this will come earlier than the flight critical part. Mission criticality is mostly driven by the defense developments, and we see that more and more customer requests are placed around building these components into the products, as well as into the, what you mentioned there as the mission autonomy, more on the MDCC. So I think this is a more coming sooner than the flight critical functions.
No, it's a question for Philippe Koffi, precisely. So you can't duck this one. Are war games a way to create data necessary to train the AI algorithms?
Sorry, I missed the...
Are war games a way to create data necessary to train the AI algorithms?
Yes, it's a part of the answer. War games, simulators are a way to generate this vast amount of data. I could have mentioned this in my speech, because we'll see how operators, commanders will adapt courses of action and so on, and AI can we can rely on this to train our future algorithm for sure. But it's only a part of the answer.
Any questions from the floor?
I tried to raise a question through the system, but I didn't succeed. So I have a question. I have a question about the operational experiments that you mentioned. So what are the actual operational experiments that you conduct or that you have in mind, and how would you characterize the gap, if any, between what we do in Europe and what is performed in the US on experimenting AI functions in military system, in combat aircraft or...
So, for instance, there are discussion, and I'm not sure there are current tests about this, but there are ongoing discussion, for instance, to test how we can use AI to accelerate the artillery chain, and how we can use drone to target and retarget, and to have something which is much more faster and more precise. And as I mentioned, there are also ongoing talks to have operational experimentations to develop this, or to test this kind of Shazam tools for electronic warfare. So drones, electronic warfare, Tiger helicopters. So there are many talks with the French, the armed forces, and the DGA. And I hope that in the next months, we will transform this. I have no direct view on what's going on beyond what I mentioned about this partnership between Boeing and Shield AI in the CCA program.
Maybe I can add a few comments there. So yesterday it was mentioned in one of the presentations, the concepts around manned-unmanned teaming and the demonstration of ISR capabilities with an Airbus Flight Lab helicopter and the Leonardo UAV. This was conducted recently. It was in the month of September this year, actually. So these are, I think, good building blocks which will test around not just the battle management system and the combat scenario, but also the other type of mission scenarios. I think we are operationally testing them this way. Another example that I could give is the Automate demonstrator, which was an Airbus demonstrator, defense and space demonstrator, finished a couple of years ago, where we experimented and actually demonstrated two things. One is the air-to-air refueling. The second was the automated assets cooperative control from within the tanker aircraft. So it would be to take control of the UAVs, which we are refueling, or rather the aircrafts which we are refueling from within the tanker aircraft, and to ensure that the positioning is right, so the boom control unit can make the contact using vision. So this was another topic. So there are some demonstrations which are happening, I think, which are going in the direction of some ISR operational scenarios testing?
I think it's difficult for me to listen to this conversation without mentioning the initiative between Helsing and Saab that was announced a week ago in the International Fighter Conference, in which we will jointly make a demonstrator in which the Helsing AI will take over the full control of a Gripen aircraft during a beyond visual range air-to-air scenario. Beyond the achievement that I think it is, and to come back to your earlier part of the question, we absolutely have the talents in Europe to be on par with the US on this. Maybe they're 2 years early, but we're catching up fast, and we do have the talents in Europe. But in order to attract and retain and give the critical mass to these talents in Europe, you need strong AI players, which is what we're trying to build with Helsing.